10 discoveries that suggest we are not alone in the universe. Let's begin. Number 10. The molecule that only life produces. In September 2023, the James Webb Space Telescope detected dimethyl sulfide in the atmosphere of a planet designated K2-18b, a star 120 light-years from Earth. On Earth, dimethyl sulfide is produced almost exclusively by marine phytoplankton, living organisms processing nutrients in ocean water. It has no confirmed non-biological production pathway at the concentrations detected. K2-18b is 8.6 times the mass of Earth. It sits in the habitable zone of its star, the region where liquid water can exist on a surface. The habitable zone is not a guarantee of life. It is a prerequisite, a necessary condition, not a sufficient one. But K2-18b satisfied it, and then Webb found something in its atmosphere that went further than temperature and distance. Webb detected carbon dioxide, methane, water vapor, and then dimethyl sulfide, 4 molecules. 3 of them explainable by geology and chemistry alone. The 4th with no known geological or chemical explanation at the concentrations observed. The detection method was transit spectroscopy. As K2-18b passed in front of its star, starlight filtered through the planetary atmosphere. Different molecules absorb different wavelengths of light. The resulting spectrum is a chemical fingerprint, precise, repeatable, unambiguous at sufficient signal strength. The Webb team was careful with their language. The signal was weak, a 3 sigma detection, below the 5 sigma threshold required in physics to claim a confirmed discovery. Confirmation required further observation. They did not claim life. They described a detection and published it. The paper appeared in the Astrophysical Journal Letters in September 2023. It has not been refuted. No alternative production mechanism for dimethyl sulfide at those concentrations has been proposed in the peer-reviewed literature since. A follow-up observation program using Webb's NIRISS instrument was approved specifically to increase the signal-to-noise ratio of the dimethyl sulfide detection. Those observations are ongoing. The results have not yet been published. What is known is this. Dimethyl sulfide has appeared in a planetary atmosphere twice in the history of astronomy. The first time was Earth, the second time was K2-18b. And the only process we have ever observed producing it is life. Number 9. The ocean beneath the ice. Europa is a moon of Jupiter, 3,100 kilometers in diameter, slightly smaller than Earth's moon, covered entirely in a shell of water ice, fractured, refrozen, geologically active at the surface in ways that imply something moving beneath it. Beneath that ice, a liquid ocean, confirmed not by a single measurement, but by decades of converging evidence from multiple independent missions. The Galileo spacecraft detected a magnetic induction signal at Europa between 1995 and 2003, a signal consistent with a conducting layer beneath the surface. Salt water conducts electricity, ice does not. The depth of the ocean is estimated between 60 and 150 kilometers. The volume exceeds all of Earth's oceans combined. At the bottom of that ocean, a rocky silicate seafloor in contact with liquid water, heated from below by tidal forces generated by Jupiter's immense gravity, pulling Europa in one direction, while the gravity of Ganymede and Io pulls it in another, stretching and compressing the moon continuously, generating heat through friction in the rock itself. The same mechanism that drives hydrothermal vents on Earth's ocean floor, vents where superheated water rich in hydrogen sulfide and dissolved minerals erupts from cracks in the seafloor. Around those vents on Earth, entire ecosystems exist. Tube worms, shrimp, crabs, bacteria, archaea. None of them dependent on sunlight. None of them connected to the photosynthetic food chain that sustains almost everything else on Earth. They live entirely on chemical energy, on the reaction between the vent fluid and the surrounding seawater. Europa has the same energy source, the same chemistry, the same darkness, and it has had them for billions of years. In 2023, the James Webb Space Telescope detected carbon dioxide concentrated specifically in Terra Regio, a region of geologically young disrupted ice where the surface has been fractured and refrozen repeatedly. The concentration pattern was inconsistent with external delivery by meteorite impact or implantation by charged particles from Jupiter's magnetosphere. The spatial distribution matched what would be expected if the carbon dioxide had originated in the subsurface ocean and migrated upward through fractures to the surface. Carbon is one of the 6 elements considered essential for life, CHNOPS. Carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. All 6 have now been either detected or inferred in Europa's ocean environment. NASA's Europa Clipper spacecraft launched in October 2024. It will arrive at Jupiter in 2030. It will conduct 49 close flybys of Europa. Its instruments will map the surface chemistry, measure the depth and salinity of the ocean, search for active plumes erupting from the surface, analyze any material ejected from beneath the ice. If Europa is venting ocean material into space, Europa Clipper will fly through it. It will taste it, the same way Cassini tasted the plumes of Enceladus and found organic molecules and molecular hydrogen and everything life needs. Europa has been waiting in the dark for 4 billion years. Europa Clipper will arrive in 6. Number 8. The signal that has never been explained. On August 15, 1977, astronomer Jerry Amon was reviewing data from the Big Ear radio telescope at Ohio State University. Big Ear was part of SETI, the Search for Extraterrestrial Intelligence, a program scanning the sky for radio signals that could not be explained by natural astrophysical processes. Most of what Big Ear detected was noise, interference, known natural sources, pulsars, quasars, the background hiss of the cosmos. Then Amon found something different, a signal lasting 72 seconds, the maximum duration Big Ear could observe any point in the sky as Earth's rotation carried the telescope past it. The signal was narrowband, concentrated at a single frequency, 1,420 megahertz, the frequency of hydrogen, the most abundant element in the universe, a frequency that physicists had long argued any technologically advanced civilization would use for communication. Because any civilization capable of building a radio telescope would know about hydrogen, would recognize 1,420 megahertz as a universal reference point. The signal was strong, extraordinarily strong. It registered at 30 times the background noise level. Amon circled the printout in red pen and wrote one word in the margin. Wow. The WOW signal has been studied for nearly 50 years. It has never been detected again. Every attempt to relocate it has failed. In 1995 and 1999, the Lovell telescope at Jodrell Bank pointed at the same coordinates. Nothing. The Allen telescope array has repeatedly observed the same region of sky. Nothing. In 2020, a paper proposed the signal originated from a hydrogen cloud associated with a sun-like star designated 2MASS 192819882-2640123, approximately 1,800 light-years away in the constellation Sagittarius. The paper was not universally accepted. The proposed source is a sun-like star in the right location. But the hydrogen cloud explanation struggles to account for the signal's extraordinary intensity and narrow bandwidth. A hydrogen cloud does not produce a signal 30 times background at a single frequency. Natural radio sources do not behave that way. The WOW signal had every characteristic SETI was designed to find. Narrow band, strong, at the hydrogen frequency, from a fixed point in the sky. It appeared once, it has never appeared again. And no natural explanation proposed in nearly 5 decades of analysis has been accepted by the scientific community as definitive. Number 7. The building blocks are everywhere. In 2022, the Japanese Hayabusa 2 spacecraft returned samples from the asteroid Ryugu to Earth. Ryugu is a carbonaceous asteroid, a Type C asteroid, among the most primitive objects in the solar system, material left over from the formation of the planets 4.6 billion years ago. Largely unchanged since then. The samples were analyzed by multiple independent laboratories across Japan, the United States, and Europe. What they found inside a rock that had been drifting through space since before Earth existed was unexpected in its specificity. Amino acids, 23 of them. Acids, 23, including several that are among the 20 amino acids used by life on Earth to build proteins, uracil, one of the 4 nucleobases that make up RNA, the molecule that carries genetic information in living cells, the molecule that many researchers believe preceded DNA as the information storage system of early life. Vitamin B3, niacin, a molecule essential to cellular metabolism in every living organism on Earth. The paper confirming the findings was published in Nature Communications in 2023. The amino acids were not contamination. The isotopic ratios confirmed they were extraterrestrial in origin, formed in space, before the solar system existed, on an asteroid that had never been anywhere near a living organism. The significance is profound. The chemical precursors to life are not rare. They are not confined to Earth. They form spontaneously in space from simpler molecules under the influence of radiation and time. They survive billions of years on the surfaces of asteroids. They are delivered to planets by impacts. Earth was bombarded by carbonaceous asteroids and comets throughout its early history. The amino acids in Ryugu are chemically identical to those found in meteorites that have fallen to Earth. The same molecules, made the same way, in the same environments, distributed across the solar system, and by extension across every planetary system in the galaxy that forms around a star with the right chemistry. Life on Earth may not have started from scratch. It may have started from a delivery. Number 6. Mars. Had everything life needs. 3 billion years ago, Mars was different. A thicker atmosphere, a magnetic field protecting the surface from solar radiation. Liquid water, not traces, not brines. Oceans, rivers, lakes, a hydrological cycle, clouds, rain. A planet that by every measure we use to assess habitability was habitable. We know this not from theory, but from direct evidence collected by a fleet of spacecraft that has been studying Mars continuously for decades. The Curiosity rover has been driving across Gale Crater since 2012. Gale Crater is an ancient lake bed. Curiosity has analyzed the sedimentary rock laid down at the bottom of that lake. It found mudstones, formed by fine particles settling slowly through standing water. It found sulfate minerals formed by evaporation. It found organic molecules, carbon-bearing compounds preserved in ancient rock for 3 billion years. Tholins, thiophornes, benzene, propane. In 2018, Curiosity detected seasonal variations in atmospheric methane. Methane that appeared in summer and faded in winter. On Earth, the primary source of atmospheric methane is biological activity, microorganisms producing it as a metabolic byproduct. Mars also has a geological methane source, serpentinization, water reacting with certain rock types at depth. The seasonal variation, however, was harder to explain geologically. Geology does not follow seasons, biology does. The Perseverance rover landed in Jezero Crater in 2021. Jezero is an ancient river delta, a place where a river once flowed into a lake and deposited sediment carried from hundreds of kilometers upstream. Perseverance has been collecting rock cores from the delta sediments, cores that will be returned to Earth by the Mars Sample Return mission. Those samples have not yet been analyzed in terrestrial laboratories, but the rocks Perseverance is coring from are exactly the kind of rocks on Earth where ancient microbial life leaves fossil evidence. Silica-rich sediments, carbonate deposits, fine-grained mudstones laid down in shallow water. Mars had the conditions. Mars had the chemistry. Mars had the time. 3 billion years of habitability before something went wrong, before the magnetic field collapsed, before the atmosphere thinned, before the water froze or escaped to space. Whatever was living there, if anything was living there, had 3 billion years to establish itself before the planet changed. The question is not whether the ancient environment could have supported life. The evidence confirms it could. The question is whether it did. Number 5. The radio bursts that come from everywhere. Fast radio bursts are millisecond flashes of radio energy, intense beyond anything known in nature. In a single millisecond, they release more energy than the sun produces in 3 days. They arrive from cosmological distances, billions of light years away. They were discovered in 2007 when astronomer Duncan Lorimer found one archived in data from the Parkes Radio Telescope in Australia. Collected in 2001. Since then, hundreds have been detected. Most appear once and never repeat. Some repeat. The repeating ones are stranger. In 2020, a fast radio burst designated FRB 2020012 OE was traced to a globular cluster in the galaxy M81, approximately 11.7 million light-years away. Globular clusters are ancient, dense collections of old stars, not environments associated with the young neutron stars and magnetars currently favored as the leading natural explanation for fast radio bursts. In 2022, a fast radio burst was detected originating from within our own galaxy, from a known magnetar designated SGR 1935 plus 2154. This confirmed that at least some fast radio bursts have a natural magnetar origin. But magnetars in globular clusters are not expected. Old stars do not produce young magnetars. The energy released by some fast radio bursts exceeds what any known natural mechanism can produce at the observed distances. The repetition patterns of some repeating bursts show structure. Periodicity. Subbursts arriving in clusters with gaps between them, inconsistent with purely stochastic astrophysical processes. None of this is confirmation of an artificial origin. The natural explanations have not been exhausted. What is true is that fast radio bursts represent a phenomenon discovered less than 2 decades ago. That remains incompletely explained. That originates from across the observable universe, and in at least some cases displays properties that current astrophysical models struggle to account for. Hundreds of them arrive every day, most are never detected. The sky is full of them. Number 4. The chemicals of life form in space without any help. In 2022, astronomers using the Green Bank telescope in West Virginia detected 2 new molecules in a cold, dense cloud of gas near the center of the Milky Way. Ethanolamine, the simplest form of a class of molecules called amino alcohols, and nitrile, both detected in a region of interstellar space with temperatures near absolute zero, where no chemistry was supposed to be happening efficiently. Ethanolamine is a component of cell membranes. The phospholipid bilayer that forms the boundary of every living cell on Earth contains ethanolamine as a structural element. Finding it forming spontaneously in interstellar space means the molecular precursor to one of the most fundamental structures in biology assembles itself in the coldest environments in the universe. From nothing more than simple atoms and radiation, this was not an isolated finding. Previous detections in interstellar space have included glycine, the simplest amino acid, sugars including glycolaldehyde, a 2-carbon sugar that can react with other molecules to form ribose, the sugar backbone of RNA, phosphorus-bearing molecules, formamide, tamborad, which can react under radiation to produce all 4 DNA nucleobases simultaneously. The chemistry of life does not require life to begin. It requires time. Radiation, simple starting materials, carbon, hydrogen, nitrogen, oxygen, sulfur, phosphorus, all of them abundant throughout the galaxy. All of them reacting spontaneously in interstellar clouds to produce molecules of increasing complexity. Molecules that then accrete onto dust grains, get incorporated into comets and asteroids, get delivered to planets during bombardment phases. The galaxy is running a continuous chemistry experiment across trillions of cubic light years of space. It has been running it for 10 billion years. The products it is generating include the molecular building blocks of every living thing that has ever existed on Earth. Number 3. There are more habitable planets than stars. In 2011, the Kepler Space Telescope produced a statistical analysis that changed the scale of the question permanently. Based on its first year of observations, Kepler's team calculated that on average every star in the Milky Way hosts at least one planet. The Milky Way contains between 200 and 400 billion stars. The implication was that there are at least 200 billion planets in our galaxy alone. Then the analysis refined further. In 2013, a paper in the Astrophysical Journal estimated that 22% of Sun-like stars in the Milky Way host an Earth-sized planet in the habitable zone. 22% of Sun-like stars alone. The Milky Way contains approximately 10 billion Sun-like stars. 22% of 10 billion is 2.2 billion. 2.2 billion potentially Earth-like planets in the habitable zones of Sun-like stars in our galaxy alone, not counting the planets orbiting red dwarf stars, which are far more numerous, and which Kepler data suggests host habitable zone planets at even higher rates, not counting the moons of gas giants, which in our own solar system include Europa and Enceladus, both of which have subsurface liquid water, not counting subsurface oceans on ice worlds like Pluto. The total number of environments in the Milky Way where the conditions for liquid water exist likely exceeds the number of stars. The nearest potentially habitable planet to Earth is Proxima Centauri b, 4.24 light-years away, orbiting in the habitable zone of Proxima Centauri, detected in 2016. Its atmosphere is unknown, its surface conditions are unknown, but it is there, at the nearest star to our Sun, a planet in the habitable zone. The universe did not make one of those. It made billions of them. Number 2. Enceladus is venting an ocean into space. Enceladus is a moon of Saturn, 500 kilometers across. In 2005, the Cassini spacecraft detected enormous geysers erupting from the South Pole, jets of water vapor and ice particles shooting 200 kilometers into space. Cassini did not observe them from a distance. It flew directly through the plumes, multiple times. Its mass spectrometer analyzed everything the plumes contained. Water ice, sodium chloride, the same salt as table salt dissolved in Earth's oceans, Silica nanoparticles formed when water at high temperature reacts with rock, carbon dioxide. Molecular hydrogen, produced by serpentinization, the same chemical reaction that feeds hydrothermal vent ecosystems on Earth. Complex organic molecules with masses above 200 atomic units, large enough to be fragments of more complex chemistry, possibly amino acids, possibly lipids. The analysis published in Science in 2017 described an environment at the bottom of Enceladus's ocean that was chemically indistinguishable from the environments on Earth, where chemosynthetic life thrives without sunlight. Every ingredient was present. The energy source was confirmed. The liquid water was confirmed. The organic chemistry was confirmed. The only ingredient not confirmed was life itself. Cassini ran out of fuel in 2017. NASA made a deliberate decision. Rather than leave the spacecraft in an orbit that might eventually bring it into contact with Enceladus, they crashed it into Saturn, a $1 billion spacecraft, deliberately destroyed, to protect a moon. You make that decision only if you believe there is something on that moon worth protecting. A dedicated Enceladus mission has been proposed. Designs exist for a spacecraft that would orbit Enceladus directly, fly through the plumes repeatedly, carry instruments sensitive enough to detect individual organic molecules and amino acid sequences in the ejected material. As of 2024, no such mission has been approved. The plumes are still erupting. The ocean is still venting its contents into space. Everything needed to answer the question is already in orbit around Saturn, waiting to be collected. Number 1. The conditions for life are not the exception. They are the rule. For most of the 20th century, the assumption was scarcity. Earth was special, its distance from the sun, its size, its magnetic field, its moon stabilizing its axial tilt, its plate tectonics recycling carbon, its liquid water ocean, its oxygen atmosphere. Each factor seemed improbable. The combination seemed extraordinary. Then the data arrived. Kepler found that planetary systems are not rare. They are universal. Every star has planets. Earth-sized planets in habitable zones exist around billions of stars. The chemistry of life forms spontaneously in interstellar space. From the simplest available ingredients, amino acids fall from the sky inside meteorites. Organic molecules assemble themselves in cold molecular clouds, at temperatures near absolute zero. Liquid water exists not just on planetary surfaces, but beneath the ice shells of moons orbiting gas giants. Europa, Enceladus, Titan, possibly Pluto, possibly Ganymede, possibly Callisto, all of them with liquid water in contact with rock, with chemical energy for billions of years. Mars was habitable for 3 billion years before something went wrong. Dimethyl sulfide, produced on Earth exclusively by living organisms, has been detected in the atmosphere of a planet 120 light-years away. The radio sky contains fast radio bursts arriving from billions of light-years away, with energies that current models cannot explain. A signal detected in 1977 at the hydrogen frequency, from a fixed point in the sky, has never been explained and never been detected again. Taken individually, each of these findings has a proposed natural explanation. Taken together, they point in one direction. The ingredients for life are universal. The environments suitable for life are counted in the billions. The chemistry of life assembles itself from first principles without any help. The one planet we know hosted life did so within a few 100 million years of its formation. We have not found life beyond Earth, but everything we have found in the last 30 years has made the absence of that discovery harder and harder to explain.